Hi, folks. Welcome to the session. We're going to be talking about .NET2Fox. Now, what is this? Is this some kind of utility for converting .NET applications to FoxPro? No. And I struggled with a bit with the name of this. I suppose the full name would be .NET to Visual FoxPro COM Interop Helper. That just rolls off the tongue, doesn't it? So .NET2Fox it is. And basically it offers an alternative to that classic COM approach we all learned, classic COM interop approach we all learned years ago. And it just aims to simplify things while also providing more flexibility. Before we get into it, just a little bit about me. Last year's Virtual Fox Fest was actually my first time giving a full session at a conference. It's a little bit out of my comfort zone, but for some reason they asked me back, and so I'm happy about that.
Hey, Joel.
I am the project manager for Parallel Fox and Fox Tabs. And also, and those are on VFPX. I'm also now the creator of .NET2Fox. Should that be on VFPX? I'm interested to hear what folks think about that.
Hey, Joel.
Yes.
You aren't sharing your screen.
Oh. Sorry, I couldn't hear you. Just a minor inconvenience there. Okay, should I start over?
No, you're fine. Just go ahead.
Okay. I occasionally blog at joelleach.net, much less than I intend to, which I think probably describes just about every blogger out there. But take a look. There might be some topics of interest to you there. And besides that, I'm just a software developer. I've been working with FoxPro and its predecessors for a long time now. And over the years, that's expanded into SQL Server, .NET, and others. And I'm happy to be employed at MBS now for 21 years and counting. So on the agenda, we're going to answer that question in detail. What exactly is .NET2Fox? And then we're going to talk about basic usage of the library and demonstrate that in a desktop application. We'll discuss the .NET2Fox Pool Manager and how that can help you with web applications. Then we'll get into asynchronous calls. Yes, .NET2Fox supports async and await. We're also going to look at how that affects performance and just the overall performance characteristics of .NET2Fox. Then we're going to demonstrate how you can extend .NET2Fox with your own code, and then talk about error handling and debugging. There are a few things I'm not going to have time to go over in this session, but that are in the white paper. Installing .NET2Fox into your Visual Studio project. That's just a NuGet package. There's a discussion on garbage collection and COM objects in the white paper and some decisions that were made around that with .NET2Fox. And also in regard to deploying your .NET2Fox with your .NET application. And if you have any questions, enter those in chat, and I will stop periodically and ask Rick if there are any questions. Okay, let's get into it. What is .NET2Fox? Well, this is a library that really grew out of necessity. And over the past several years, I've been working to surface some features from my FoxPro desktop application, make them available on the web via ASP.NET. And I found that the classic approach to COM interop, recommended by Microsoft, it's been a couple of decades ago now, just didn't really fit my needs. And so this library sort of emerged out of that over time, and it's now being released into open source. Okay, that sounds great, but what exactly does it do? So I think to explain that, we'll jump right into code. And I'm trying to turn off my camera. There we go. Okay, so walking through this, Fox start here, that starts up an instance of the DotNet2Fox COM server, and that's written in Visual FoxPro. It also returns an instance of this Fox class, and that's how we interact with the COM server. And this object has various methods on it for executing FoxPro code, and eval is one of those. So here we're just evaluating this FoxPro expression that's within this string. And first we just have some text here, and then we're going to pull the caption from the VFP window, as well as the date time. That's going to be returned to .NET, and then we're going to write that to the console. This is all wrapped up in a using block, which should be familiar to most C# developers. And this is just an indication that the Fox class implements the iDisposable interface. And basically that means at the end of this block, the Fox object is disposed of, which in this case means that the COM server is going to be released and closed. So let's run that. And it's taking a minute. I think the video slows it down a little bit. There we go. Okay, so there's our text, there's our caption, Microsoft Visual FoxPro, and the date time. So this probably looks a little bit different from the classic COM approach, you know, right? And I keep mentioning this classic COM approach. Has COM really changed since, say, the late 90s? Not really, but there are some interop features that have been added to .NET since then. So back in 2010, C# added the dynamic keyword that just makes it easier and more natural to work with COM objects. So DotNet2Fox takes advantage of this feature, this keyword, and provides a generic interface for executing FoxPro code, while also trying to reduce the limitations often associated with COM interop. So let's go ahead and review that COM interop approach that Microsoft recommended back in the early 2000s when .NET first came out. So I've got a class here, and it's marked as OLE public to indicate that this is in fact going to be visible over COM. And in our hello method, we've just got this string, and again, we're just returning the date time. Now, this would be built into preferably a multi-threaded DLL. That's the recommendations that were made back at that time. And if I actually built it, I would get an error because I would realize I forgot to start Visual FoxPro as an administrator. And I would close VFP, restart it as admin, run through that process again. At least I found that's my workflow when working with COM objects. So fortunately, this DLL is already registered on my machine, so I don't have to do that. So going to .NET now, I'm going to first switch this project. I'm going to have to do that several times during the session. And to reference that COM object, I would right-click here and click Add COM Reference, and select the COM, classic COM library that I created in FoxPro. And I've already done that, so if you look under the COM references, you can see it there as well. Okay, and this is all basically the same as we've learned years ago. And then using that object is very easy. We just instantiate that COM object, call the hello method on it, and then we're going to write that to the console. So I'm going to run this. And again, it works. And there is nothing wrong about this approach. In fact, there are some advantages to it. For one thing, calls across this COM boundary are very fast. And these multi-threaded DLLs they're made within the same process or the same thread as .NET. And therefore, they're not as fast as, say, native .NET calls, but they're fast to other methods of COM. They're very efficient. These multi-threaded DLLs make efficient use of resources. So multiple threads or apartments within the DLL, they share the same VFP runtime. So that keeps memory usage low. When you bring that COM reference into .NET, it automatically gives you IntelliSense for that object, and that's nice. So I did start to go down this road because I wanted to take advantage of these things and kind of do things the recommended way. But unfortunately, our app did not fit into this mold. And it quickly became apparent this approach just wasn't going to work for us. And there are a number of reasons for that. First of all, these multi-threaded DLLs don't support all the features of VFP. One of the big missing features is just the report engine is not there. But beyond that, there were some features included that sometimes worked a little bit differently. And those things could require adjustments to the app. So due to those limitations, it might require significant refactoring just to make things function inside the DLL. Simply marking our classes as OLE public, that wasn't going to work for us. When you expose new interfaces over COM, that requires rebuilding, redeploying, and re-registering the COM DLL. So maybe you have a feature already in your FoxPro app, and now you just want to expose that to .NET via COM, right? To do that, you're going to have to add new interfaces to the COM object, and that's going to require you to distribute both the .NET assemblies and the VFP COM components, and then keep those in sync moving forward. Another issue is that there's no live debugging support. So you're expected to test and debug your classes within the VFP IDE ahead of time, and you don't really have a way to step into FoxPro code while you're running it from .NET. You don't have control over how many threads or apartments run inside the multi-threaded DLL or over their lifetime, how long that they stay in existence. Speaking of apartments, these COM DLLs use the single-threaded apartment model, and web apps must be configured to run on these same type of STA threads rather than the more efficient .NET thread pool. So I'm not sure if it's still the case, but I know at one point there were some types of web apps in ASP.NET that didn't even have this as an option. It wasn't possible to do that. Accessing 32-bit COM DLLs, it requires your .NET app to be compiled as 32-bit. And I've run across this issue a couple of times. If you forget to do this and you run your .NET app, it's going to just tell you that the COM object is not registered when you know good and well that it's registered on your machine. And you're like, oh yeah, I need to change it to x86 32-bit. There's no support for async and await with this model. COM actually does define an interface for async, but it's optional. And as far as I could tell, that was not implemented with VFP COM objects. I think even if it was, it would have to be translated to work with the .NET async and await anyway. So those are some issues. How does DotNet2Fox address these shortcomings? Well, to start, DotNet2Fox uses out-of-process COM exe servers, and these support the full feature set of VFP, including reports. Because you have these reduced limitations, it should lead to reduced refactoring, and DotNet2Fox has ways to help you set up your environment and also to run code anywhere within your app, not just within classes. Now, note I'm saying reduced refactoring, not no refactoring. So there might be some work that needs to be done for you to run in like this server mode, right? So for example, if you have code that pops up a message box to prompt the user in the middle of a process, you're not going to be able to run that on a web app, right? That message box would just be hidden on the web server somewhere that nobody could respond to. So for those types of things, some refactoring is going to be required. But just this idea that you have to do some refactoring just because you're running a multi-threaded DLL, that's not a limitation. DotNet2Fox includes a very simple generic COM object. That's the only piece that's registered, and it's going to rarely change. So this lowers the coupling between the .NET and the VFP apps. And by that, I mean, previously we said, if you have this existing feature in your FoxPro app and you just need to access that, maybe that you don't really need to change anything in the FoxPro app. This is going to allow you to do that. And then you would just need to distribute the .NET assemblies, not necessarily the FoxPro pieces. DotNet2Fox has support for live debugging while running your FoxPro code from .NET. And we're going to show that later. It includes a pool manager that provides full control over the number of Fox instances, as well as how long they will remain in the pool while idle. Since we're using the out-of-process COM server, it doesn't require any changes to the ASP.NET thread model. You can just use it as you normally would. And for that same reason, it works with 64-bit .NET apps. And we have optional support for async and await, as we're going to demonstrate later. Of course, there are some trade-offs, and the pros of multi-threaded DLLs tend to be the cons of using DotNet2Fox, right? These out-of-process EXEs, any calls you make between .NET and FoxPro, they're just not as fast as an in-process multi-threaded DLL. Now, the difference will usually be negligible, but if you have code that's crossing that COM boundary, say hundreds of thousands or millions of times within a loop, that's going to add up. So that should be factored into your design choices. A DotNet2Fox instance is going to use more memory than a DLL. And again, this is relatively small on today's hardware, but something to keep in mind. And since we are using these generic dynamic method of COM interop, it doesn't come with IntelliSense. Now you can create your own wrapper classes in .NET around the COM object, and then those classes would give you IntelliSense, but it's not something that's built in. So for my needs, the pros of DotNet2Fox that just far outweighed the cons. Okay, let's talk about basic usage of the library. And first, a quick word about system requirements. First of all, we're using VFP9, SP2, so any code you want to run needs to be compatible with that. As far as .NET versions, it'll work with .NET Framework 4.6 through 4.8, as well as .NET 5.0 and presumably higher. Specifically not supported are .NET Core 1.x through 3.x. So those were the predecessors to .NET 5. And the reason is that DotNet2Fox requires certain COM interop features that just weren't available in those versions. But .NET 5 completed that story. As far as language support, C# and X# both work. So we're going to show an X# example later. VBNet works with some limitations. You have to have option strict off. And I found that it only worked with .NET Framework 4.x. So apparently those additional COM features they added in .NET 5 were only for C#. So VB left out in the code a little bit there. but maybe that'll be handled in a future version of VB. Okay, so DotNet2Fox gives you several methods of executing your FoxPro code, often mirroring the way code is called in VFP. So one way is just a simple do command, and this just executes a single Visual FoxPro command. Eval, we've already seen that. That evaluates an expression and it returns the result back to .NET. How many thousands of times have we used the do command to execute a FoxPro program? Okay, we can do that in DotNet2Fox. Similar to do is call, and this one executes a function and returns the result. So this could be a VFP built-in function. It could be your own user-defined function that you've written, or even a method on a global object that's already in memory. You could use it to call a method on that object. This one is sort of a shortcut. It instantiates an object, calls the method on it, then releases the object. So it's just handy when you need to call a single method on an object and then you're done with it. Often you need more than that. So create new object, that just instantiates VFP using the standard built-in new object function. And once you get an object back from that in .NET, you can work with it directly, calling methods, setting properties, whatever. And last but not least is exec script, which it works just like it works in VFP, right? You pass multiple lines of code as a string, and it's going to execute them and return the result. So let's look at some code demonstrating this. Again, I'm going to change my startup project and look at some code here. And this is a Windows Form desktop application. So I just put a lot of the code in button clicks. So here's a simple example, just showing that basic formula again. We're using Fox start to start up the COM server. We're calling, using the Fox object, methods on the Fox object to execute FoxPro code. So in this line, we're just doing a do command, and we're going to change the directory within FoxPro to this Northwind path that I've defined up here higher in the code. Then we're going to call this full path function. And if you call that with an empty string, that just returns the current directory, including the drive letter. So the way you would call that is using this call method, the name of the function, and then any parameters that you want to pass to that. That's going to return the current path back to .NET, and then we're just going to demonstrate that or display that in a message box. Again, this is wrapped up in a using block, and then at the end of the block, the COM server is going to be closed and released. So let's run that. And there we go. That's the directory that FoxPro is in, and that's where I expect it to be. So that's working. For the FoxPro side of things, the rest of our examples, I created an app using the Northwind sample database and the application wizard that ships with Visual FoxPro. Anybody use that before? That wizard makes use of the application framework and the Fox Foundation classes that are also included with VFP. Now, of course, I didn't put together a bona fide production application here, but that wizard and framework, it did allow me to quickly put together some forms, some reports, and classes that are somewhat representative of real-world code. So the main program is this Northwind_app, PRG. If I go back to .NET, our next example is basically to start up that app, right? Can we get past the startup stage? So first of all, in this start, I'm setting debug mode to true, and that's going to allow us to see the VFP window so we can see what's going on. And I've got some startup code that again changes to that Northwind app. And then I've also got a set procedure to Northwind app. That's going to allow DotNet2Fox to see and execute code within that app, right? Just as you would expect. And that's exactly what we do next. We're calling that Northwind underscore app PRG. One of the things that program does is it creates a global application object, and that has a caption on it, which is just the name of the application. So we're going to return that back to .NET and display that in a message box. So let's see if this works. So here's our FoxPro window, and interestingly, I can actually interact with it, even open up some forms, navigate. Okay. But if I click back to my .NET, oh, guess what? I can't click back to it. It won't even become visible. What happened? The .NET app is stuck. Well, read events happen, right? That's just a standard part of every FoxPro desktop application. But in this context, it prevents control from returning to the calling .NET code. So I can exit the app here, but then I'm just going to get an error in .NET on the subsequent code because that Go app, right, it no longer exists. So when running as a COM server, read events should not be used. And the app framework with VFP actually supports running in this mode. But I did need to make a couple of modifications to take advantage of that. So here in our startup program, Northwind app, I added a parameter just so we would know when it's being run from .NET2Fox rather than as a desktop application. And if I go further down, I can see here that I'm setting this read events property, which is on that global application object, to false. And then that's going to later prevent the read events from actually happening. So what I need to do on the .NET side is just change this property to true. That's that .NET2Fox parameter. And if I run this again, I'm no longer going to get the read events. And there's the caption that I was expecting to get. So let's look at another one. Here's our startup code again. And this time we're going to use call method. It's going to instantiate the customer's object, which is within customer's PRG. And we're going to call the get customer method on that object and pass it a customer ID. So let's peek at that code in FoxPro. And basically that just runs a query to get the specified customer. It scatters it to this LO customer object, and then it returns that object. And then back in .NET, we're reading properties from that FoxPro object and putting them in a formatted string and just displaying that string in the message box. So I'm going to run that. And there we go. There's the customer information that we retrieved from FoxPro. The next example is similar to that. In this scenario, let's suppose that this company has an employee card and they're strict about what's included on that card and how it's formatted. Maybe there's some regulations around this. And this code to format that card is already in VFP. So we would like to reuse it here in our .NET app. So here's our startup code again. And this time we need to call multiple methods on an object. So we're going to use create new object. And because this is in a VCX, we have to include this Northwind app parameter, because that VCX isn't compiled inside of the Northwind app. Otherwise, DotNet2Fox is not going to be able to find that class library. And so this set procedure 2, you would think, well, maybe that'll take care of it. That's going to work with things like PRG files, but for the DBF-based source files like VCX, SCX, FRX, it doesn't handle those. So, so this additional parameter is going to be required to find it within the app. And once we have that employees object, we're going to call get employee and pass it an employee ID. That's going to return an employee object, singular. And we're going to pass that object to this format employee card method that creates the card string that we want. And then we're going to display that in a message box. So running that, there's our employee card formatted as we expect. Moving on to the next example. Here's our startup code again. This is getting old, isn't it? And are we really going to have to duplicate that code on every request? Well, no. .NET2Fox includes some application hooks where you can insert code like this. So that's in this examples Fox app class, and I'm going to go to it. And this class implements the iFox app interface that is included with .NET2Fox. And for the desktop application, we really only care about 2 hooks. We'll talk about the others later, but that's start app and end app. So start app is executed when a new instance of the .NET2Fox COM server is created, and whenever that Fox start is called, right? And this contains that same startup code that we've been looking at this whole time. Then end app is going to occur whenever the COM server is closed, which is at the end of that using block. So here we're calling this release method, which is part of the VFP application framework. On shutdown would, I'm sure, have handled this as well, but this seemed to be like the preferred way to do it. So going back to the previous code, we're also going to show a FoxPro script. So here's a string, and we're just opening the Northwind database. Then we're using a local view within that database. That's going to, of course, give us a cursor, which we are converting to JSON via the NF-JSON project, which you can find on VFPX. We're going to close that cursor and then return the JSON. Now, for short scripts like this, it's fine to do this directly in your C# code. For longer scripts, it might get a little unwieldy to do it this way. And C# just doesn't have that nice text-in-text structure that we have in VFP. But as an alternative, you can actually put your code in a PRG file. And this is the same code, and you'll notice that Visual Studio even does a little syntax coloring for us. And if you do that, you're going to want to change the build action here to embedded resource. And what that's going to do is include the PRG inside of the .NET assembly, so you don't have to distribute it separately. When you do that, at runtime, you're going to need to pull it back out of that assembly, which there's a utility in the examples for that, get embedded resource. And that's just going to read the file and put it in a string, just the same as if we had defined it above. Either way, we've got a JSON string here. Well, we're going to run that script first. That's going to return the JSON. And that's converted into a .NET data table because that's what you want to display inside of the data grid. And then we set that data table to the data source of the grid. Okay, that's a lot of things we talked about. Let's see if it actually works. Yes. So I've got my local view displaying here in a .NET grid. Okay, what about VFP forms? And you don't typically think about running forms in a COM interop scenario, right? Ideally, all your business logic is in classes, right? Non-visual classes. And I know that all of my code is perfectly separated into clean tiers, as is yours. But maybe somebody else's code isn't, and you need to run that. Or maybe you do have code nicely separated into these other classes, but then you use a form method to pull multiple classes together for a process. And in that scenario, maybe just calling that method on the form might be the easiest thing to do. But you might have noticed I didn't mention a do form function in DotNet2Fox earlier. And there's a reason for that. So let's look at some code. Here I've got a script that attempts to create that form, right? And it uses the name clause, so that'll put it in an object reference. Uh-oh. Come back, Visual Studio. Okay, good. And then it's going to return that reference. And so when we execute that script, we should have a COM reference to that form. Then we're going to execute a couple of methods on that form. First, we're going to find the order that we're looking for. And then the real business logic that's tied up in that form, calculate order total. We're going to get that and display it in the message box. Okay, let's try to run this. We get an error. Orders SCX does not exist. So what happened? This is the same issue I mentioned a minute ago about DBF-based files, right? DotNet2Fox is not able to find it within the Northwind app, and FoxPro doesn't give us a nice in Northwind app clause that we could use here, or else that would just be the solution to this. What you have to do instead is have a function inside the app that DotNet2Fox will be able to see and execute that function to run the form. And fortunately, again, that VFP framework does give us a way to do that. So on that global application object, it has a do form no show method. I tell it the name of the form I want, and that is returned. The reference to that form is returned to .NET, and then the rest of the code is the same. Let's try this again. And yes, it works this time. I have an order total for the specific order that I wanted. And we're going to, this works, but we're going to actually improve on this solution a little bit better later. But this naturally leads to the next question, right? Can you actually display a VFP form within a .NET form? And technically it's possible, but I found that the two windowing systems didn't mesh well. And that said, I didn't put a lot of time into it. With more experimentation, it might be possible to get something working, but that's not something I'm going to be showing you today. How about reports? Let's use X# for this example. And we've got a run report function here. And a lot of this code, this is using the VFP dialect, so a lot of this ought to look familiar, but there are some things that are X# specific, like here's our using clause, right? That's not something we would use in standard VFP, but here's the syntax for using it within X#. And basically all we're doing is calling this export report to PDF, PRG, and I have included that this time within my FoxPro project. And so you can see here that it just uses Foxy Previewer, which you can find online. It's open source. And I just went to their website and basically copied and pasted some code to generate a PDF. Now, because we're using this preview clause here, that's going to open up the PDF in the viewer, and FoxPro will be opening that. But in a real world app, you would want to instead return that PDF back to your .NET app and let it handle distributing it or displaying it. But for DemoWare, this is good enough. So we've got our code here in X#, and this is just in a class library. If we go back to our Windows form, this is still C#, but you can just instantiate that X# object. .NET allows you to do that, but across multiple languages. Then we're just calling that run report and passing it the name of the report we want to run. So let's actually run this. And there you have it. There's our report exported to PDF. So that's it for this basic usage section. Before we talk about the pool manager, are there any questions?
Yes. Are there any limitations to the number of parameters that you can pass to the call, do, etc. methods, or are you supporting basically the number of parameters supported by VFP6? I'm sorry, not just VFP6.
It's just going to be the standard FoxPro limits, which is going to be 26 parameters, I believe, but some of those parameters might be used by some of the built-in parameters of DotNet2Fox. You know what? I think I realized my problem here with my sound, why I can't hear you. So let's hope. Can you still hear me?
I can.
Okay, now I can hear you. Okay, any other questions?
No.
Okay. So DotNet2Fox includes a pool manager that can be used to keep multiple Fox instances in memory and available to service requests. So the idea is to avoid that startup hit on every request, right? And this is particularly useful for web applications, but even in those desktop examples we saw, you might not want it to close that Fox instance and then take a startup hit every time you need to use FoxPro, right? So in that scenario with a desktop, if you did want to keep that Fox instance open between requests on the desktop app, you could use the pool manager, but just set the pool size to 1. So that's how you would handle that. Speaking of pool size, there are a few settings on the pool manager that can be configured. And I'm going to close this. Now we're going to work with this web app. And in the startup of the app, I have several properties that I'm setting here. So the pool size is what you think it is. It's the max number of Fox instances that can be active at any given time. So you have control over that. And it defaults to 1 instance per CPU core. That's not necessarily a recommended amount. It depends on your usage, right? And the expected load that you have and what else is happening on that server. So let's say that the web app is the only thing on that server. You might want to have up this to 2 or 3 instances per CPU core. On the other hand, if there are other things running on the server, like SQL Server, other web apps, then you might want to reduce the size. So you're just trying to find this balance, right? You don't want DotNet2Fox using up too many resources, but you also don't want to have a situation where you're constantly waiting on a Fox instance to become available because your pool is not large enough. Fox timeout. It's the number of seconds an existing Fox instance is going to remain in the pool before it's released and closed. So you've run a request. that created a Fox instance. Your request is complete. It gets put in the pool. If it waits there for this specified number of seconds and doesn't get used for another request, we're going to go ahead and close that instance to reduce the resources. And the default here is 60 seconds, but you can change that to whatever you like. And we talked about those application hooks, right? You need to tell the pool manager which class to use for those. And that's done via the set Fox app type. And once you set this, the Fox pool is then going to instantiate that class for each Fox instance that's created in the pool. So let's see how this pool manager is used in a Razor Pages application. And rather than using Fox Start, I'm using Fox Pool Get Object. And that's basically how you make use of the pool manager. Everything inside the using block is the same as if you had used Fox Start. So here's our code again for the employee card. But notice here that we are setting the string, the employee card string, to a public property on this employee model class. And that's just the basic way that you make it visible to the Razor page itself, which contains the HTML, and this part is responsible for rendering the page. And so there's that employee card property right there. And at the end of the using block, rather than closing the instance, it's returned back to the pool so that it can be reused again for a subsequent request. So let's run this real quick. Or not real quick. And there's our employee card. Now I want to go back to our application hooks. And taking a look at them. So when you're using the pool manager, the start app is going to be called only when the pool manager determines that a new Fox instance needs to be created, right? So if you already have objects in the pool and then those can be used to service the request, this won't be called. But if a new instance does need to be created, then this code will be called, and you'll only take the startup hit at that time. On the other hand, start request is called before every request. And this is a good place to put commands that are scoped to a VFP data session, or some environment settings like set reprocess, if your Fox app is not already doing that. It also might be a good place to do something like pass in a user ID from the .NET app to the FoxPro app, or anything else that might change for each request that you want your FoxPro app to know about. End request, conversely, is called after every request, and I didn't have any code I needed to put here. And then end app is going to be called when the Fox instance is closed and released. So again, that's going to occur after it's been sitting in the pool and the timeout expires. That instance will be closed, and this code will be called then. So going back to that code again here, let's talk about this key parameter. This is a required parameter when you're using the pool manager. And it could be used as a tenant ID. It basically provides a named instance of your Fox object. So one way you could use that, as I just said, is as a tenant ID for multi-tenant scenarios. And then maybe your FoxPro app translates that to a data path or a connection string, somehow pointing at the data for that tenant. Another scenario is if you have one .NET app that calls into multiple VFP apps. So maybe this app makes use of, this .NET app makes use of the Northwind app. And then maybe it has some requests that call into the TazTrade app, right? So you could use this key to designate which app is being loaded by the instance. So it's just a way to differentiate this instance from other instances in the pool when you need to do that. And if you don't need these separately named instances, you can just pass it any string. What I've done is just use Northwind, the name of the app. And so you could do something like that. This key does affect how the pool manager obtains an instance from the pool, and to make sure it's done in an efficient way. So here's a flow chart that talks about how that's done. So we start here. And the first question is an instance with the specified key available in the pool? Meaning it's already running, sitting there in the pool, waiting to be used for a request. So let's say we're passing in the Northwind key. I'm looking for any instances in there that have already been started up using the Northwind key. The answer is yes. Grab that instance and use it to service this request. The answer is no. Then we ask, is the number of current instances less than the pool size? And the number of instances includes any instances that are currently busy servicing requests, as well as any that are sitting in the pool waiting, perhaps with different keys. Okay. So if the answer, if that number is less than the pool size, then yes, we have room in the pool to create a new instance. So create that instance and then use it for the current request. If the answer is no, we're going to have a small delay, and then we're going to go through that process again. But we're going to do it a limited number of times. If after that limited number of times, we still aren't able to find an instance to use, we're going to take it a step further and say, is there an instance with a different key waiting in the pool? So I'm trying to find, this is a Northwind request. Is there an instance in the pool that is using the TazTrade key? Okay. The answer is yes. We're going to steal that slot from TazTrade. And that means we're going to close that existing TazTrade instance and then create a new instance for Northwind. And the reason we're doing that is because the TazTrade instance is just sitting there doing nothing and just using up a slot. So if the answer is still no, we're going to have that delay again, small delay, and then just retry the whole operation again. Now, if your code gets stuck in this loop for an extended amount of time, that means you need to increase your pool size. And if that makes your server struggle, you might also need to look at hardware upgrades. There is an alternative to this flow, but check out the white paper for that. So let's look at another Razor Pages example. And this time, we're going to get two COM objects. One is just an object and one is a collection. So I'm first going to create this customer's object, and then I'm going to call the get customer to get a singular customer, and that's an object. I'm also going to call this get customer sales, and that's going to run a query. And that just returns an alias, right? We can't read a cursor directly from .NET. So once we have that alias, we're going to convert that to a collection this time. And that collection is going to be returned to .NET, and that's I've named that orders here. And just like we did before, I'm going to set both of these objects to public properties on this model class, this .NET class, so that they will be visible to the Razor page. And so you can see here, we're rendering certain properties from that FoxPro object. And then also we've got a table here that's going to render the orders for that customer. So let's run that. And it didn't work. COM object has been separated from its underlying RCW. Well, why did that happen? Well, notice here that we're dealing with COM objects, not primitive types like strings and integers that you could that you could just cross right over. And so these objects actually live within FoxPro, but I've set them to these public properties outside of the using block, basically causing them to leak outside of that block. And DotNet2Fox actually is going to proactively release these COM objects so that when the Razor page tries to render information from those objects, they no longer exist. So you get that error that we saw. So how do we deal with this? The best solution is to copy the values from those COM objects over to native .NET objects. Okay, so here's a .NET object, a customer class, and that's defined down here. And this just has some places to put the data, some properties for that. And it's the same for customer order, just some properties to put our data. And so now we're copying the values from the FoxPro customer COM object over to the .NET object. And then for the orders, we're creating a list that's based on the customer order. And then we're going to iterate through the FoxPro collection and again, add those to the list and then copy the values over for each object. And now if I save that, that's going to refresh. And now it works. So yes, it's a little bit tedious to do that. But the moral of the story is don't let your COM objects leak outside of that using block. I actually like to take that even one step further and put all of my .NET2Fox code in a separate project, a separate class library. So we're going to work with this web API project now. And if I look in the dependencies here, you notice there's no .NET2Fox package here. This is where it would show up. But I do have a reference to this Northwind legacy project that I've created. So if I go up to that project and I look under the dependencies, there's my .NET2Fox package, right? And so all of my FoxPro interactions are going to occur within this legacy project. And this is known as the anti-corruption layer pattern. And so the idea is that only .NET types are going to go in and out of this legacy project. You're not going to return any COM objects, any FoxPro specific stuff. All of that happens inside the project. And all code outside of the project that needs to interact with these legacy objects can just do it the .NET way, right? The way that it's expected to. So this gives you a clean separation between the two, and it doesn't let, you don't have to worry about any limitations in, that could be caused with the rest of your code. So let's look at how that's done. And here I've got a get sales data method. And here's our script again to open that local view and convert it to JSON. And what we're doing in this case is we're deserializing the JSON into a list of this sale DTO type. And if I go up here, that again, this is just a class that just has places to put the data, right? And in fact, it's called a data transfer object. That's where the DTO comes from. And that's basically the only reason it's there. And we also made an optimization here. So this JSON is just a string, right? Just a primitive type. And once that's generated, FoxPro is done, right? So why not go ahead and just close the using block here? That's going to immediately release the FoxPro object back to the pool so some other request could use it, right? That's better than saying putting the rest of this code inside the using block. Then the FoxPro object wouldn't be released until after the deserialization occurs. So just a little bit of optimization there. And of course, this is going to return that list. If we look at the controller within the web API, that's just going to instantiate that sales object from the Northwind legacy project and just call that method on it. So from the controller, just very simple. So let's run this. And the web API gives us this very nice Swagger interface for interacting with the API. So if I go down here to sales and just run this, here's our result. Some nicely formatted JSON returned from that local view in FoxPro. Now, you might be asking, why not just return the JSON directly from FoxPro instead of converting it to this list first, like we did here, right? I've got JSON here. That web API is only going to take this list and convert it back to JSON, right? And you could actually do that. You could return the JSON directly and save a few clock cycles. But there's a few considerations why you might want to do it this way. First of all, this list gives you a strongly typed version of the data from the legacy project, right? So that provides you with more information about it as opposed to just a JSON string, right? And it also allows you to work with it more on the .NET side. So outside of the legacy project, I could maybe do some filtering or sorting on that list. Also, since we've put this in legacy code in a separate class library, we don't necessarily know how it's going to be used, right? So it might be used by Razor Page rather than a web API. And in that case, it would be really handy to have this list rather than just some JSON string. And notice here in the Swagger interface, if we scroll down, it actually gives us an example of what the data is going to look like before we even run it. Now, I did create a version that returns just the JSON, and you can see the difference here is it just says it's a string. And so if I run that, then we get the same JSON. It's not as nicely formatted because Swagger doesn't know as much about the data. But you know what? This is completely functional. If you wanted to do it this way and save some clock cycles, you certainly could. So follow your own preference on that. Do we have any questions on the pool manager?
None at this time, Joel.
Okay. Let's talk about async. Asynchronous programming has caught on in a big way in the .NET community. And that's partially because the C# async and await keywords just make it more easy and more natural to use. Now, as most of us know, asynchronous roughly means running something in the background so that the foreground thread can do other things. And while this could be some long-running process, say in C# code, an async method is most often used when you're actually running something outside of .NET, or more specifically outside of the .NET thread pool. So this could be you're reading a file from a disk, you're running a query in SQL Server, you're running a request on some other web server across the internet, input-output types of things that sort of already have this built-in latency in them. So why should a .NET thread wait around twiddling its thumbs while one of these external processes is running? And it doesn't have to, and that's where async and await come in. These free up the thread to do other work while these external processes run. And when you use this in desktop applications, the objective is usually just to keep the UI responsive while some code runs. For web apps, the focus is more on conserving threads. So by freeing up threads to service other requests while that external process is running, then a given number of threads can handle more requests using async. And this can be important for web servers that are under a heavy load. Now, I mentioned before that DotNet2Fox uses out of process comm servers. That sounds like an external thing, doesn't it? So you might be thinking, this sounds like a perfect opportunity to use async, and you'd be right. DotNet2Fox has support for async and await for this reason. So each of the ways I've showed you of executing code has an async version. So we have the do, we have do async. We have call and call async, exec script and exec script async. So we're going to look at that one. And that's up here in my legacy. Oh, same code here. So here's the async version of that same code, showing the pulling the local view into JSON. This time I'm running it with exec script async. And that, in conjunction with the await, is going to free up this .NET thread while the exec script is running. It could run another .NET request. Now note that this only frees up the .NET thread. Okay, it doesn't free up the FoxPro instance. That instance remains reserved for this particular request within the entire using block. Until that using block ends and the request is complete. And that's going to occur after the JSON has been returned from the script. Notice that we also called getObjectAsync up here, and that has an await as well, giving the code another opportunity to service another request. So that affects our application hooks because we have a couple of async hooks for the startup. And this might actually be handy, right? That Northwind app, your startup code might actually be one of the longer running things in your app that might take a couple of seconds. So it might be worthwhile to call it asynchronously while that startup is running. .NET can be doing some other things. But whenever you call that getObjectAsync, it calls start app async instead of the standard start app. So that's an important bit of information. If you're using both getObject and getObjectAsync within your application, you need to make sure your startup code is in both places. The same thing for start request async. And in this case, I didn't have any code that I needed to run asynchronously, right? All I have is this set reprocess. That's something that's going to take very little time. So I didn't want to call it asynchronously. So I just forwarded the request to the standard start request, forwarded the call to the standard start request. And that said, this interface still requires a task to be returned. So to do that, we just return this built-in completed task. Okay, what about running methods directly on an object? So employee. Here's that employee card example again, right? So we have our employees object, and now we're running two methods directly on that employee's object, right? DotNet2Fox is not getting in the middle and handling those calls. It would be nice if we could call these two methods asynchronously. And to do that, you can use call object method async within DotNet2Fox. And if you use this, you pass it, first of all, the object, the name of the method you want to execute, and any parameters that you want to pass to that. And the same thing here for the format employee card. Now, notice that I've got an await before each of these calls. If you took this out, what would happen is the get employee method would start running, and then it would immediately try to also run the format employee card method, which is expecting the return value, this employee object that's returned back from get employee. So you would get an error. But notice that the C# compiler doesn't even complain about this. So that's something to be aware of. You need to, before each async call in .NET2Fox, you need to include that await. Now, of course, this is not as pretty as the code up here, but it does give you a way to execute that code asynchronously. So we've got this async way of running code in .NET2Fox. Should we do it for every .NET2Fox to call? And we're about to talk about performance, but any questions on async so far?
Sort of related. Does .NET2Fox have any instrumenting behavior to log performance of your requests?
Well, we're about to show performance. It doesn't have anything built into that, but you'll be able to look at the examples. And there are a lot of them. We're only going to show a couple here, but there are a lot in the code that you could look at various ways of, detecting how long a request takes. And we're about to show one of those.
Okay, that's it.
Okay, performance. So some .NET developers subscribe to an async everywhere approach, using it anytime it's available. And so is this appropriate when for .NET2Fox calls? And the short answer is no. Using async carries some overhead on both the .NET and the FoxPro sides. And I put together a variety of performance and load tests just to kind of help decide when it's worth using async, and to also provide an overall idea of how .NET2Fox performs. Now, these tests were performed on hardware available to me, and of course, your mileage may vary. So for our first test, I just wanted to find out how long does it take to make an individual call over using .NET2Fox, meaning including any comm interop, as well as just the way you make calls in .NET2Fox itself, overhead from .NET2Fox itself. And so this is just a simple eval call, just adding two numbers. It's the easiest and quickest call that you could probably make. And so we're obviously not measuring the performance of this call, but the overall overhead of .NET2Fox. Now, I have to emphasize this is not, we're not timing the entire request, right? We're excluding the startup time. So we're doing startup here. That's going to create the Fox instance, as well as run, if there was any startup code, it would also run that. And then here's where our stopwatch starts. So again, we're just trying to get how long a singular call takes. And I've just done it 100 iterations of that just to give an average rather than just having a single sample. Okay, so let's run that. Okay, so to run all 100 of those calls, it took 20 milliseconds, or about 0.2 milliseconds for each call. Not too bad, right? Now here's an async version of the same test. So let's run it. And this one took 198 milliseconds, 1.98 milliseconds for each call. So I still think that's negligible, but it is 10 to 15 times longer than the non-async test, right? So even though we have this VFP-COM server running in a separate process, there's still going to be some calls that are very fast and not worth the async overhead. So the idea that every call to VFP should be async doesn't really apply with DotNet2Fox. So I actually have a program, a PRG, that's a couple thousand of lines of code. It contains multiple functions, but on average, it takes 0.5 milliseconds per call to run. I kind of expected that async was going to help me here. But that particular piece of code was designed to be high performance. It's called a lot. And so the point being, it's not about the amount of code. Even if you have a lot of code, it can run very quickly. It's about what that code's doing, how long that operation takes, and what kind of latency there might be built into that. So let's get a little bit better idea by looking at some load tests. And before we get into that, let me just say you have to take these load tests with a grain of salt. They often don't represent real world loads. Results aren't always consistent. It's often the same request running over and over again, which could cause more than the usual contention for resources on the FoxPro side, because you've often got this same piece of code all running at the same time, perhaps trying to access the same file, right? That's going to cause some contention delays. Async will often perform slower because the bottleneck ends up being with the FoxPro instances in the pool rather than the .NET threads, which is where async really helps out. So all that said, I at least want to give you an idea how DotNet2Fox is going to handle heavy loads and just what kind of overhead it brings. So for our load testing environment, I used a Windows Server on an Azure VM using the full IIS, not Express, and 8 CPU cores. So this would be basically a production style environment, okay? Although everything was done on a local disk, we didn't access any files or data over the network. All of the web requests were done on the local machine. And Westwind Web Surge was used to perform those load tests. Now, it has a setting where you can specify the number of threads. And this represents how many requests are hitting the web server simultaneously. And it's not the same as the number of threads that ASP.NET would be using on the server side. Okay, so they're different things. But Web Surge just constantly hammers that server with a full load for however many threads you specify and for a specified number of seconds. So with that in mind, each of those threads actually could represent dozens of real users, right? Depending on how much traffic your application generates. But you shouldn't get the idea that one Web Surge thread equals one user. It would actually be more than that. And again, your mileage may vary in your environment. So I first wanted to find out with the load test, what's the max throughput of DotNet2Fox using pure, every call is a DotNet2Fox call. So I set the pool size to 8, which was 1 per CPU core. I set the web surge threads to 12. I found that was sort of a sweet spot with this pool size. And so that gave us 644 requests per second was the max throughput. And on the async side, it was lower, and that was actually expected with this type of test because all we're demonstrating is that there's overhead for async with this. So this is not the thousands of requests per second you'll see with, pure .NET test along these same lines. But I think once you get into real world requests, it's going to be sufficient. And my next load test is more realistic. It's a mix of some FoxPro requests and some of .NET only requests. Some requests are long, some are short, and we put the server under heavy load. So in this example, I increased the pool size to 24, where it was 3 per CPU core. And I pushed web surge up to 96 threads. So that means, yeah, 96 requests are going to be constantly hitting that server at one time. And we see in this case, we got 153 requests per second with just the normal sync test. And that's seems okay, but look at our average response time, 700 milliseconds. That's getting up there a bit and might be borderline unacceptable. Async did better in this type of test, and we have 253, and I think our average response time is in a more acceptable range. There are more tests in the white paper. In the examples, I spent way too much time doing this. But from those, I came up with the following conclusion, that async is going to do better under the following conditions. First of all, when you're not running that same request over and over. When some requests take longer to run, perhaps because they are pulling data from disk or over a network. When there's a mix of DotNet2Fox and .NET only requests, not every request being a call to FoxPro. It's helpful to use async if you increase the pool size higher than the number of CPU cores. Because of the way the thread pool works, async will be able to more readily take advantage of those additional Fox instances. And as we saw, whenever the server really is under a heavy load, async is going to do better. Now, on the other hand, if your app is, say, an internal app that's not going to experience a heavy load, the load's going to be pretty low, yeah, consider whether it's even worth using async, whether that additional complexity, the additional effort that it brings is worth doing. Okay, let me ask again, do we have any questions?
I do not see any at this time.
Okay. So we previously talked about why DotNet2Fox could not include that do form method, right? And that makes sense, but you know, I really would like to have my own implementation of that do form method that you could call right on the Fox object, just like you could call those built-in methods of executing code. Is there a way to make that happen? Why, yes, there is. Thanks for asking. This would be the perfect use for .NET's extension methods. And if you're not familiar with these, extension methods allow you to add methods to an existing class in .NET without subclassing it. So let's see how that's going to look. Here I have a do form method, and you'll notice this might look kind of odd if you're not familiar with these. It has a this keyword in front of the first parameter. And so that's the telltale sign that this is an extension method and that it's going to extend this Fox class. And then this do form, within that, we're just calling that do form no show that I showed earlier, passing it the form name, and then returning that to .NET, a reference to that form. And we're doing the same thing. The framework also gives us a release form method, and I've created an extension method for it as well. So to see how that's actually used, here in this order total method, again, I'm just calling Fox do form this time, right? It looks just like any other call on the Fox method, and returning that form. And so that's a simplified way to do it. There is one minor limitation, and that is that dynamic objects cannot be passed as parameters to extension methods. So I've got this form, it's dynamic type. And if I just passed it to this release form, then I would get an error from the compiler that I couldn't do that. It's just a limitation. But the way you work around that is by casting it as an object first, and then it'll just work as you expect. Another potential use for extension methods, maybe your framework includes some kind of factory for creating objects rather than using the standard built-in create object or new object in VFP. You could create an extension method for that, and then to call that factory, and then that would return an object. It would just be just as easy to use as the built-in create new object in DotNet2Fox. Error handling. This is an area where you're going to at least have to make some minor modifications to your FoxPro application. We need some way to notify .NET of when an error occurs. And I wrote a script here that shows you the basics of how to do that. So first of all, I'm causing an error in VFP and just using this message as the error message. And then that's going to be go into the catch clause. And com return error is what notifies .NET that an error occurs, right? This is a com object, that makes sense. But unfortunately, it does not return the actual error message. And this is a .NET limitation that happens whenever you call a method on a dynamic object, as DotNet2Fox does, right? I mentioned earlier that we make use of that dynamic keyword. So if you call the method on a dynamic object, rather than using these previous techniques like interop wrappers, reflection, stuff like that, then you unfortunately don't get the error message back from FoxPro. So to deal with this, we first set the error message on a public property on a global object. So that's going to be set to this underscore screen error message property. And that's the default, but that's something you could configure if you wanted to change it. And there's one other issue, and that is that com interop is not available when you run DotNet2Fox in debug mode, because that's running your code within the VFP IDE, as we're going to talk about later. And com return error is just not available in the VFP IDE. So to work around that, you can call cancel instead. And that will raise the error in .NET, and then DotNet2Fox will go out and get that error message. So let's run that. Now, reading .NET stack traces is always a joy, but you can see right here at the top is that .NET2Fox test error message. And of course, your FoxPro error handler is going to return more information, right? The file name, where it occurred, the line number, maybe even the stack trace from FoxPro. So there would be more here. Further down in this stack trace, you see that the error occurred in .NET on line 29. So if I look at line 29, that's the exec script call. So the error is going to give us information about what happened both in .NET and FoxPro. Now I had to add similar code to my VFP app, and it's buried a little bit here, but I found where error messages are logged, and then I just added this code to that method. So we first check to see if we're actually running this from DotNet2Fox. If we are, we set that screen error message property. Then we either do com return error, or if we're in debug mode, we use cancel. Okay. So this will handle any errors that occur within our application. And I'm going to cause an error. So in this case, I'm just going to use a table that doesn't exist. Okay, so here's our FoxPro error file bad table name does not exist. And this error handler actually returns more information from FoxPro. And here again, the error occurs on line 37 in .NET. If I look at that, that's exactly where the command that I called. So every method on the Fox object that executes code will automatically retrieve this error from FoxPro and report it to .NET. But we have that scenario where you're executing a method directly on a FoxPro COM object. And in that case, some additional work is required. So here's our employee card example. And since we're calling these methods directly on this employee's object, all we need to do is wrap those in a try catch. And then within the catch, call the handle error method on the Fox object and pass it the exception. Then DotNet2Fox can go out and get that error message and report it back to .NET. So if I run that, okay, so I get an error. LO employee is not an object. And notice in this case, in the .NET portion, I get two line numbers in the stack trace, line 50 and line 54. So if I look at those, line 50 is where the error actually is. And line 54 is just my call to that handle error method. It'll report both of those in the stack trace, but this is the one that you actually care about. And I can see that, oops, based on the error message FoxPro gave me, I forgot to pass employee to that method, my employee object. Now, after an error occurs, DotNet2Fox will release and close the Fox instance. So this might be a little bit different than your FoxPro app, right? It probably handles errors more gracefully and keeps the app open so that the user doesn't have to close it and restart it. But I found this approach more reliable when using DotNet2Fox, okay, to go ahead and close that instance. But just keep in mind that with the normal operation of DotNet2Fox, it's going to create those new Fox instances when it needs them. So whether you're using the pool manager or Fox start, your next request that comes in, it's going to create that new Fox instance, giving it a clean environment to run after an error occurs. Do we have any questions?
None at this time.
Okay. Let's talk about debugging. We're in our final section. Wouldn't it be nice that while stepping through .NET code using the Visual Studio debugger, if you could just seamlessly step into VFP code within a COM object as well? I agree, that would be nice. And in fact, way back in 2000, it feels weird to say that way back in 2000, but that actually was a long time ago now. That actually was slated to be a feature while VFP 7 was in development. Some of you might recall this. You were going to be able to create VFP COM DLL projects right inside of Visual Studio. And that was also going to allow you to debug and step into Fox COM components, code within the FoxPro COM components within Visual Studio. This feature was announced and it was even demonstrated at a DevCon. And I put some links to the announcement and a video of the demo in the white paper. So check that out. And in fact, if you're like me and you enjoy FoxPro nostalgia, just watch the whole keynote video. It's a nice blast from the past. But alas, it was not to be. Shortly after that conference, .NET was announced. The decision was then made to pull VFP out of Visual Studio and make it an independent product, which was a good thing, I think. But as a result of that, the Visual Studio integration really wasn't needed any longer, and that feature was canceled. So that left us basically where we were before when it comes to COM debugging, and which is that you have to fully test and debug your components ahead of time within the VFP IDE. But there really wasn't any way to do any live debugging while the application was running from .NET. So DotNet2Fox aims to improve on that experience. And first and foremost, you need to turn on debug mode. And so here I've done that within the constructor here, just so it'll apply to all methods on this object, and just by setting debug mode to true. And as I mentioned before, that is going to run your FoxPro code within the VFP IDE rather than in the DotNet2Fox COM server. And by doing so, this gives you access to all features of the IDE, including the debugger. It also makes that VFP instance visible on your development computer so you can see what's going on. Now, once you have debug mode turned on, the most straightforward way to debug is just to put a set step on statement in your FoxPro code. So I'm going to do that. And I've got my get customers method here. I'm just going to call set step on here. I'm going to rebuild that because DotNet2Fox will be looking for it within that Northwind app. And now if I run that, I can see my FoxPro instance, and there's my code. And of course, I've got the debugger here. I can do everything you can normally do within the debugger. I can step through this code. I can examine the properties on that customer object. If I needed to do stuff in the command window, I could do that. Everything you would expect. So that works, but it might not always be convenient to add that set step on to your FoxPro code. So there's an alternative. So to demonstrate that, I'm going to first take this out and put it back like it was and rebuild it again. So what I can do is within the .NET code, I can add a set step on here. Oops. I can type. I can add a set step on here. So, and it might just be more convenient to do that in your Visual Studio code that you're already working with, rather than going to the FoxPro site and adding it there. That's all this is here for. But what it's going to do is once you've set this on the next subsequent call, whether using any of the methods to execute code, it's going to run a set step on before that call. So in this case, set step on is going to occur before get customer is called. So let me show you that. And now my set step on has occurred, but notice I'm not inside my the Northwind code. I'm inside of .NET2Fox code, right? And what's going to show you has a comment in each place that this can occur, telling you what you can step into below to get inside the code you actually want to debug. So in this case, since I'm using call method, I actually have two options. I could step into new object, which would just put me into the init of that object that I'm instantiating, or I can step into the method call, which is what I want to do in this case. So I'm going to first step over these lines of code, and then I'm going to step into the method call, and there's the code again that I want to debug. So that's set step on. What about breakpoints? Well, whenever DotNet2Fox opens this VFP IDE for debug mode, it uses COM automation to do that. And unfortunately, whenever you open the IDE this way, any breakpoints that you've previously set in the IDE, they don't transfer over automatically. So DotNet2Fox gives you a mechanism for doing this. So I'm going to go back to that same piece of code, and this time I'm going to set a breakpoint as you normally would. And as you're probably aware that if the debugger is not already open, it'll open the debugger for you. This is an important bit of information. For this to actually work, you then have to close the debugger. Why is that? Well, breakpoints are saved to the FoxPro resource file. That's typically the Fox user DBF file. But VFP doesn't actually write the breakpoint to that resource file until you close the debugger. So it's a little bit of an annoyance, but you have to do that to get your breakpoints to work. Going back to the .NET code, you call Fox load breakpoints to actually load those breakpoints from the IDE, since it doesn't happen automatically. Now, if your FoxPro app that you're executing uses a different resource file than your IDE, you can pass the path of your IDE resource file, and then it'll load the breakpoints from that, the resource file that actually contains the breakpoints. And so what this is going to do is open the debugger whenever you call this, load the breakpoints into the debugger, and then any breakpoints that you have in there will take effect. So it's usually best if you have multiple .NET2Fox calls in here, it's usually best to just do this right before the method, the code that contains the breakpoint, just for performance reasons, because that debugger is going to be open. So let's run that. And there we go. There's our breakpoint. And again, we're in the debugger and can step through it. There is one other way where you can set a location breakpoint from within .NET. Check out the white paper for more details on that. Okay, before we get into our summary, are there any final questions?
I do not see any.
Okay. So what did we learn today? What is .NET2Fox? Hopefully you understand that better now. Basic usage of different ways that you can call code from .NET2Fox, and we showed that within a desktop application. Also how to use the pool manager and how that can help you with web applications. We talked about async and the impact that that can have on performance. We showed how you could extend .NET2Fox with your own code and how you can take care of error handling and debugging. So that's it. If you have any questions, you can contact me directly, or you can enter an issue on the GitHub. Again, this is open source, and you can find the repository there, that link. Also, please fill out your evaluation, even though this is pre-recorded, that should be available. And that's it. Thank you for watching.